Hello everyone. Today I will be presenting DFA minimization using the table filling method. So first one is the introduction part. So DFA minimization is the process of finding an equivalent DFA with the smallest possible number of states. One of the most systematic ways to do this is the table filling method. The steps include constructing a state pair table, marking distinguishable pairs, identifying equivalent states, and finally building the minimized DFA. So next one, concept of state equivalence. Now, what do we mean by equivalent states? Two states are equivalent if they behave identically for every possible input strings. On the other hand, states are distinguishable if at least one input string can take one state to a final state while other goes to a non-final state. Then a state pair table. To apply the method, we build a triangular table to all pairs of states. Each cell tells us whether those two states are equivalent or not. At first, we don't know which are equivalent, so only some cells are marked. Step 1. Initialization step. In this first step, we immediately mark all pairs where one state is final and other state is non-final. This is because such pairs can never be equivalent. Step 2. Iterative marking step. In this, we iteratively check all the unmarked pairs. For each input symbol, we look at the transition from those states. If the next state from a distinguishable pair, then current pair also becomes distinguishable. We repeat this process until no new markings can be made. Step 3. Finally, the pairs that remain marked represent equivalent states. These can be merged together to reduce the DFA. See example before minimization. Let us take an example DFA with 5 states. Some of the states are equivalent and we will apply the table filling method step by step to minimize it. So now we are using the JF-LAP tool to how to minimize the DFA using the JF-LAP. So in this, we click the finite automaton. So here there are the 5 editors. Now I am using a 5 states. So I click the state creator. So I need 5 states. Here I am going to mark initial and final states. So Q0 is the initial state. Q4 is the final state. Now I am going to mark here input symbols. Here I am representing the input symbols are A and B. So the transitions can be made. From Q0 to Q1, I am giving as A. Then Q0 to Q3, input symbol is B. Then Q1 to Q2, input symbol A. Then Q2 to Q1, input symbol A. Q1 to Q4, input symbol B. Then Q3 to Q2, input symbol A. Then Q2 இருந்து Q4, input symbol B. Q3 to Q4, input symbol is B. Then Q4 to input symbol A. It is a self loop. Again Q4 to Q4 self loop. In another input symbol is B. So here there are 5 states and we are using the 2 input symbols. One is A and another one is B. Now we are going to convert these DFA into a minimized DFA. In minimized DFA, the states are reduced from the original DFA. So just we click the convert menu, then click minimize DFA. Our answer is these 3 states is a minimized DFA. In first one is the initial state and the leaf nodes, there is non-final state, these are, and the final state is node 4. This is our the minimized DFA. Now the table filling method, how it works. Here's the table state pair table for DFA. First we mark all the versus non-final pairs. Then we iteratively check transitions to complete the table. Next, how the equivalent states are found. After filling the table, we identify the unmarked pairs. These states are equivalent, and by merging them, we obtain the minimized DFA. The minimized DFA can obtain by using also JFLAP tool. So next one, properties of table filling method. The table filling method always guarantees a unique minimal DFA. So next one, it works for any DFA in a systematic manner and fairly simple for small automata. The time complexity is order of n square, where n is nothing but a number of states. Finally, the applications. So the minimized DFA or DFA can use in these applications. So first one is the lexical analysis, that is compilers we used in programming languages, and in pattern recognition, then optimizing the digital circuits, and even in the network protocol verification. So thank you for everyone. Thank you for listening. That was a quick walkthrough of DFA minimization using the table filling method.